All right, the next part of our lesson is on solving equations that have radicals in them. Okay. So at the top, I want you to write isolate the radical first. So as you notice in some of the problems, like in this one here, the radical has already been isolated. In this case, it has not, because you have the -3 there, has not here, and here. Okay. So what happens when you do have something over there with the radical? We have to isolate that first and get the radical by itself. All right, so in the very first problem, it's pretty simple. First step is already done, where you have to isolate the variable. So to undo the square root, we square both sides. So 9 squared is 81. And when you square the radical, it just takes the radical away. And so you just write down what's underneath the radical, which is called your radicand, and x equals to 81, and you're done. Okay, that's a very basic problem. In number 16, first step is already done again. So we again square both sides, and it drops the radical. And 2 squared is 4, and you get a one-step equation, and you have r equals to 14. Okay, moving on down to number 17, same thing. First step is already done. Square both sides. We have 100 equals to 25x. Divide by 25. So x equals 4. So those three, first step was already done. When we look at problem number 18, we have to get rid of that -3 that's on the outside of the radical. And that -3 is being multiplied by the square root of 4n minus 4. So the opposite of multiplication, to get rid of that, would be division. And of course, like any other equation, you have to divide whatever you do on one side, you do to the other. So we're going to divide both sides by -3. And we're left with 4n minus 4 under the radical equals to 6. Next step, like we did before, once we isolate the variable, we can square both sides. So we're going to end up dropping the radical. 4n minus 4 equals to 36. We add 4 to both sides, so 4n equals to 40. Divide by 4, so n equals to 10. All right, moving on to number 19. Again, we have this -4 that's being multiplied, so we're going to divide by -4. Okay, so that gets rid of that -4 on the outside because it equals to 1 whole. We'll go ahead and bring down the x minus 10 under the radical equals to -40. Sorry, not -40, we're dividing. Okay, equals to -9. Okay, and now we're going to square both sides, so those parentheses are important. Square both sides, you're going to end up with x minus 10 equals to 81. Add 10, so x equals to 91. All right. So now when we get to number 20, we don't have anything on the outside, but we do have this +7. So like when we're solving, we always use the inverse operation. So we're going to subtract 7 from both sides. That will give us 5v plus 5 under the radical equals to 5. follow the same process afterwards, squaring both sides. So we'll have 5v plus 5 equals 25. When we subtract 5, we get 20. Divide by 5, we get 4. So I'm going to do number 22. I'm going to skip 21. It's very much like number 20, so you will simply subtract 9 on both sides. So let's go ahead and do number 22. So in number 22, you have a variable, you have radicals on both sides. So you're going to just go ahead and square both sides, and you just drop the sign. And now you can solve it just like you would with variables on both sides. I'm going to add 2x. So 2 equals to 5 plus x. And then subtract 5. So negative 3 equals to x. And that is the lesson on solving equations that have radicals.